Good morning to all my YouTube viewers. In this video, I like to discuss about test paper 2 on physics questions. And let us start the job. 3 point masses, each of small m, are placed at the corners of an equilateral triangle of side L. Then the moment of inertia of this system about an axis along one of the side of the triangle is. There are four choices. We have to calculate moment of inertia of this system about an axis along one of the side. It is to be noted here. We have to calculate with respect to one of the side. This is the side taken here. Two masses are on the axis of rotation. So point masses, so they don't need to calculate because moment of inertia for these two will be 0. Only thing we have to calculate for this, which perpendicular distance is required. A side length is L. So perpendicular distance easily we can find out, that is root 3 by 2 from here, root 3 by 2, then m root 3 by 2 L whole square. That will be the moment of inertia, 3 m L square by 4. Now come to next question. After 1 second, the velocity of a projectile makes an angle 45 degree with the horizontal. After another 1 second, it is traveling horizontally. The magnitude of its initial velocity and angle of projection are respectively taking g equal to 10. Now here four choices given, we have to find out the correct one. Now for this we can solve in this way. Let us say initial velocity u and angle of projection is theta. Then horizontal velocity will be u cos theta, vertical velocity will be u sin theta. Now after 1 second, say it has reached to this position and velocity is v, and v cos alpha will be along this direction and v sin alpha will be in the vertical direction. This position is after 1 second, and another point is given that after 2 seconds only horizontal velocity is there. What it means, definitely it has come to highest position of the projectile path. Now we will get three equations. V cos 45 degree will give u cos theta, they are equal anywhere in the projectile path. Now vertical velocity after 1 second, it will be v sin 45 degree. You can see v sin 45 degree, and here that is final velocity. Initially u sin theta was the initial velocity minus gt, against gravity it is going. So putting g here and time t 1 second, you will get v sin 45 degree means u sin theta minus 10 will come. This is equation 2, and for the highest position another equation will come, that is final velocity will become 0 here. Final velocity at the highest position will be 0. Initially it is known u sin theta, that means initial velocity, final velocity is 0. Initial u sin theta minus g into 2 second time. Here highest position reached after 2 seconds. So from here we can get u sin theta is 20. G is 10 into 2, 20. This is important for us. Now put this one here in equation 2 here. That means automatically we can get v sin 45 degree equal to 10 will come. You see, v sin 45 equal to 10 will come. Then v we can calculate 10 root 2, because this is 1 by root 2 multiplied by 10, that v will come. Once v is available, we can find out this u cos theta. I mean here in equation 1. U cos theta we can write v cos 45 as it is written earlier. So v can be replaced by v root 2, that I mean 10 root 2 into 1 by 2, 1 by root 2. This will cancel and u cos theta will come 10. That means u cos theta is 10, u sin theta is 20. Squaring and adding we can get this one. left side sin square theta plus cos theta will come equal to 20 square plus 10 square, that will give 500, and that means u will be root under 500, which is 22.36 meter per second, as it is asked in the question initial speed. Now come to direction, I mean this tan theta, that is sin component, that is this one, u sin theta equal to 20, and u cos theta already have seen, that is also 10. So dividing this to tan theta will be 2, and from here we can get tan inverse 2 will be the. Now question number 3. Here a block of mass 1 kg is over a plank of mass 2 kg. The length of the plank is 2 meter. The coefficient of friction between the block and the plank is 0.5, and the ground over which plank is placed is smooth. A constant force 30 Newton is applied on the plank in the horizontal direction as it is shown in the figure. The time after which the block will separate from the plank is. We have to find out time required to separate between these two block and the plank. For this we will see that limiting value of friction will experience between the block and the plank. Between block and the plank there will be limiting value of friction, that is maximum value is mu mg, mu into normal direction is mg. So the net force available for the plank will be, as it is 30 Newton given, minus this friction force, that is mu is 0.5, m is 1 kg, and g is 9.8. Then you can get 25.1 Newton, 25.1 Newton. Then acceleration of the plank will be divided by mass. This will be the acceleration. Then time will be half a into t square. T will be root under twice distance travelled by a. And it is that small block and big plank will between them distance is only 2 meter, because separation means that that block will be at its own position. Because force is much greater than the limiting value, so it will be remain at its own position, and that plank will just get out of it, that position. That means thereafter it will fall on the ground. Now time will be, after substitution you can get 2 into 2 divided by 25.1 by 2, so 2 will come in the numerator, it will give 0.73 seconds. 0.73 seconds. Answer will be choice number 1. 0.73 seconds you can see here. Now next question is, a boy of mass 30 kg starts running from rest along a circular path of radius 6 meter with a constant tangential acceleration of magnitude, constant tangential acceleration, this is to be noted, 2 meter per second square. After 2 seconds from start, he feels that the shoe starts slipping on ground. The friction between his shoes and the ground, I mean you have to find out, coefficient of friction you have to find out. Now as it is understood from the tangential velocity after 2 seconds will be 4 meter per second, and at that juncture, say this is the position, and there will be centripetal force because of its circular motion. That means it will be v square by r is the centripetal force, centripetal acceleration v square by r, and tangential is given constant acceleration, that is. So resultant acceleration on the boy will experience that is root under v square by r whole square plus s square. Substituting all values we can get 3.33 meter per second square. Now the condition for slipping has to overcome limiting value of friction, that is m resultant acceleration is this one. Now bring it, this will then our target to find out mu, m will get cancelled, that means resultant acceleration over g. If we divide this to, it is very close to 0.33 something, so 1.3 will be the answer as it is given here. Value of mu, answer will be B, 1/3. Now next job. A light rod of length 200 centimeter is suspended from the ceiling horizontally by means of two vertical wires of equal length tied to its ends. One of the wire is made of steel and is of cross-sectional area 0.1 centimeter square, and the other of brass of cross-sectional area 0.2 centimeter square along the rod, at which distance a weight may be hung to produce equal stresses in both the wires. This is to be noted, equal stresses. Now we know that stress means force applied over cross sectional area. You can stresses are equal T by cross sectional area, T2 by cross sectional area of the other one. So T2 will be twice T1. That relation will be available according to the given condition. Now let us say steel wire left side and brass is right side. From steel it is x distance away that weight to be hung. To get this situation, stresses will be same. Now this is x, then other length will be L minus x. Now from here, if you take torque from moment from this point, from hanging point, that means moment for this weight need not to take, that means T1 into this perpendicular distance will give a moment clockwise, that means dot will be the direction, I mean into the cross will be the direction, I mean into the paper. Then here it is in the other side, I mean anti-clockwise. So moment will be dot, that means it is going upward. These two will be equal, balancing. That means you can say T1 into x equal to T2 into L minus x. From here we will get a relation of x, we can subject here, and we will get T2 over T1 plus T2 into L will be the relation. From the previous T2 equal to twice T1 we can substitute and we can get 2 by 3 L is the length, and length is 2 meter, already it is given in the problem. So x will be 4 by 3 meter from the steel wire. Answer is A. Now come to job number 6. Two cylinders A and B fixed with piston contains equal amount of an ideal gas, a diatomic gas at 300 K. The piston of A is free to move to have constant pressure, while that of B is held fixed. The same amount of heat is given to the gas in each cylinder. If the raise in temperature of the gas in A is 30 K, then the raise in temperature of the gas B is. We have to find out what is the raise in temperature in chamber B, that is to be in cylinder B, cylinder it is. Now by this way we can do, we know the amount of heat given for both the gases are same, dq, that is n Cp dt, dt1, the pressure constant for the cylinder A, pressure is constant, so n Cp dt1 will be the relation, heat energy given, that will raise the temperature of the gas by this equation, n Cp dt. Now for the other which is fixed cylinder, it cannot increase or change volume, volume will be constant, then in this case work done will be zero. Whatever energy will be given to the system, it will increase internal energy only. That means NCV dt will come. That means from here T2 will be available. T2 will be, this is T2. You can see T2 will be, dt2 will be Cp by Cv into dt1. dt1 is given and Cp by Cv is gamma. As it is diatomic, 7 by 5 will come specific heat ratio into 30 degree change in temperature. That is, here it will be 42 Kelvin. 42 Kelvin will be the answer D. Now come to next question, number 7. A spherical conductor A of radius smaller is placed concentrically inside a conducting shell B of radius bigger. Bigger is greater than smaller. A charge small q, big Q is given to A, and then A is joined by B by a metal wire. The charge flowing from A to B will be, A has a radius smaller and B has a radius bigger, and bigger is greater than smaller according to this question. So what happens when metallic wire will be connected, entire charge will shift to B. That is the point. Total charge will shift from A to B. It will shift from A to B because charge will come at the outermost surface at low potential area. Now C will be the answer for this. Now next question 8. A 1 microfarad capacitor is connected in the circuit shown in the figure. The EMF of the cell is 3 volt and internal resistance is 0.5 ohm. The resistor R1 R2 have values 4 and 1 ohm respectively. The charge on the capacitor in steady state must be. Here as it is given, condition is steady state. Steady state means after charging process is over, this capacitor is not going to take any more charges. I mean current flow through this terminal will become 0. That is the condition for steady state. So current through this terminal is not going, so there is even bad cell is there, so current will flow through this route, only outer route. So what will happen? Internal resistance is 0.5 for the cell and this resistance is 1. So total resistance of the path will be 1.5 ohm. Therefore current will be 3 divided by 1.5 will give you 2 ampere. Once 2 ampere current is flowing, then potential drop across the cell will be, I mean from here to here or across this resistance will be how much? 2 ampere is going into 1 ohm, that means 2 volt. Or if you calculate here 3 minus 0.5 into I, that will give 3 minus 1 will come, that means 2 volt. This end to this end is 2 volt. Or you can find out here parallel in situation, so 2 volt. That means for the capacitor ends, here drop will be 2 volt, here no drop. That's why you can say drop between these two means drop across the capacitor only, 2 volt. So once V is available, we can find out charge Q equal to CV. C is 1 microfarad into 2. That means it will give us, it will give us 2 into 1 into 10 to the power minus 6 coulomb. That means 2 microcoulomb charge. Easy job. Let us come to Next job number 9. A long cylindrical wire kept along z axis carries a current of density J equal to J naught small r k cap, where J naught is a constant and small r is the radial distance from the axis of the cylinder. The magnetic field inside the conductor at a distance small d from the axis of the cylinder is, we have to find out magnetic field at a distance small d. Now Ampere's law can be used here. That is, first we have to calculate how much current will pass through up to d distance. That is required first job. Here, how to find out di? That area, you can take a small portion shown here all along, find out how much area is involved. 2 pi x or 2 pi small r into thickness is dr. So total area will be 2 pi r dr. That is the area with the shell portion, and current density is given here. J is given into density. Density means current divided by area. So ultimately current will come from this expression. Integrating, I will be available, that 2 pi J naught k cap, 2 pi J naught k cap, all these things can be taken out from the integration. By mistake another J has come here, this is a mistake. 2 pi k cap J naught, r square, one r is here, another r has come from the current density, so r square dr. So integrating 0 to small d integration, this will be the amount of current will get involved for that magnetic field generation. That is 2 pi k cap J within bracket dq over 3. Now simply Ampere's law we can use B dot dl close integration mu naught I. Substitute this I from here, and 2 pi d will be the circumference, that closed path, and from here B will be available. 1 d will cancel because d is left side, dq here, d square will become. That means it will give us 2 pi gone, mu naught d square J naught by 3 will come, mu naught d square J naught by 3 will come. Next job number 10. An object of mass 0.2 kg executes simple harmonic oscillations along the x axis with a frequency 25 by pi hertz. At the position x equal to 0.04 meter, the object has a kinetic energy 0.5 joules and potential energy 0.4 joules. Kinetic energy 0.5 joules, potential energy 0.4 joules. The amplitude of oscillation is, of course here given that potential energy at mean position is 0. So we know that kinetic energy expression for SHM, that is half mv square. We can write total energy of the SHM minus potential energy, half m omega square x square. Now these data are available. This is given 0.5, this is 0.4, so this will be 0.9, that is here, and omega is also given, and I mean m is given half here, and omega a we can find out that will be 3 because this will give 9. You can see here a square omega square will be 9. From here a omega will be 3, and omega is 2 pi by t, that is known, and 1 by t is given, frequency is given. If we put it here, we'll get 3 by 50, that means 3 by 50, that is in terms of centimeter will be 6 centimeter. it is 6 centimeter. Amplitude will be 6 centimeter. Now come to job number 11. Velocity of sound in an open organ pipe is 330 meter per second. The frequency of wave is 1.1 kilohertz and the length of tube is 30 centimeter. To which harmonic does this frequency correspond? There are choices: second, third, fourth, fifth harmonic, all these. You have to find out. This is a simple job. You know that velocity of open organ pipe, that is the that you have to know. That open organ pipe fundamental will be fundamental frequency for open organ pipe fundamental frequency will be V by twice L. V by twice L, we can get it, that is 550 Hz will come. V 330 and 2 into length of the tube is given 0.3, then we can get it 550 Hz. Now for the second harmonic, it will be twice N naught, twice fundamental, that will give us 1.11 kilohertz, which is matching with the frequency which is given in the question. So sorry, it will be second harmonic. Now 12. A point object is placed at a distance 25 centimeter from a convex lens of focal length 20 centimeter. If a glass slab of thickness T and refractive index 1.5 is inserted between the lens and the object, the image is formed at infinity. The thickness T is, we have to find out thickness of the glass which is to be inserted in between object and the lens. Now we know that image has to form at infinity after insertion of the glass block in between object, and that means object position, virtual position of the object has to be after refraction through the glass block, that virtual image will form, and I mean that will become the object for the virtual object for the next course of refraction. So it has to be at the focal point, then only image can form at infinity. That is to be noted first. Let us see. Now here we know that 1 by V minus 1 by U equal to 1 by F for convex lens, and it is given minus 20, I mean object distance is minus 25, that means it will be minus 25, that focal length is 20, so it will give us V equal to 100 centimeter. After calculation you can see V will be plus 100 centimeter. Okay, then insert one glass slab in between. To get image at infinity, object should be at focal point. Now due to insertion of the slab, glass slab, that image will shift from P position to C position. What is that shift? That shift is 1 minus 1 by mu into T. Whenever glass slab is inserted, that shift image position, I mean object position, will shift a new virtual object and that will be 1 minus 1 by mu into 2. This you have to know clearly. That means this will be, because focus is at 25 centimeter, this shifting should be 5 centimeter only, so that that virtual object will be at focal point of the lens. Then only at infinity, image will form. I mean, ray after diffraction through the lens, it will be parallel. That means 1 minus 1 by mu into t equal to 5. So, substituting here, t is available 15 centimeter. That means 15 centimeter thickness slab is required to get this type of image. Now, job number 13. An ideal massless spring S can be compressed 2 meter by a force of 200 Newton. This spring is placed at the bottom of the frictionless inclined plane, which makes an angle theta equal to 30 degree with the horizontal. A 20 kg mass is released from rest at the top of the inclined plane and is brought to rest momentarily after compressing the spring 4 meter. 4 meter. And through what distance does the mass slide before coming to rest? This is a very good job. Let us see how we can do this job. You can see in the diagram, once massless spring is connected, ideal spring is connected here at the bottom of the incline, and 20 kg block is here. Now this is 30 degree. This distance is d, and this mass will strike this one and it will compress the spring. Say after compression, it will be somewhere here at a distance x from here. From this end of the spring to here, it is x. That means spring that block 20 kg mass will travel a distance d plus x along the horizontal along the inclined plane here to here. That means d plus x. That means as there is no loss of energy due to any other any things, that is friction or any other reason, so here loss of potential energy will give the gaining spring potential energy. Say and first we have to find out what is the spring constant, because given that 200 Newton 2 meter, if compress that spring, 200 Newton force applied, it can compress 2 meters. So spring constant is available 100 Newton per meter. Now spring will store potential energy, that is half k x square, that will balance by whatever height it has come down. Suppose here, I mean here will be the position, that is loss of potential energy by the 20 kg block. That means height is d plus x into sine 30 degree, means that is the height into mg. Mass into g into total height. Height is x plus d into sine 30 degree. We have to find out x plus d, total distance travelled by the block 20 kg. Now from here x plus d we can write down in this fashion, that is k x square by mg. And now x already being told here, that x spring compressed 4 meters length. Spring compressed 4 meters. So 100 into 4 square divided by 20 kg block into small g 9.8. If you take 10, slightly different answer will come. Otherwise 9.8 will be a problematic to solve in the exam hall. Better you take 10 and nearest to the answer you can mark. That is 8.1 meter will come. 8.16 meter. Now next job. A parachutist after bailing out falls 50 meter without friction. When parachute opens, it decelerates at 2 meter per second square. He reaches the ground with a speed of 3 meter per second. when he will reach at ground, its speed will be 3 meter, end velocity, that is 3 meter per second. At what height did he bail out? I mean, where he was just started his journey. Now, for this job, it is understood that 50-meter height, without any, it will be a free fall. Now, for 50-meter height, as it is coming down, its velocity will acquire from 0 to this velocity, that is root under 1000 meter per second, because simply 2gh, I have taken 10 g10 and to 50 meter, that will be root under 1000 meter per second here. Now, when parachute opens, then only retardation will start. That means final velocity square equal to initial square. Initial will be this one, minus twice a is the retardation. The parachute after opening, this will be the retardation rate, and it will come down h dash. And h dash you can find out, that will be 247. That will be 247 meters. There is a mistake. Now 247 meter will come down. Then already it is found that 50 meter already travel without any before opening the parachute. So total distance come down, that is 247 plus 50 meter, that will be 297 meter. That will be the, and answer given this one, it is maybe 9.8 will give this answer. Now job number 15. Two blocks A and B, masses 2m and m respectively, are connected by a massless and inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitude of acceleration of A and B immediately after the string is cut are respectively. This is to be noted, that immediately after cut. That means as soon as this string cuts, this will have a free fall only. Mg, opposite force is nothing, m into acceleration of the block, that will be g, downwards along the gravity direction. Now what happens to this? Already this spring has been elongated and tension was under stable situation, it was T dash. Now immediately after cut it has to calculate, so T dash will experience in the opposite direction, because spring will reduce its length. It is being elongated, now it will compress. Now T dash minus whatever remaining mass, that is twice mg minus T, but this T is 0 here. Why? Already it is being cut, so this is removed. That means T dash minus twice mg will be the resultant force on whom? This one. But acceleration will be in which direction? Upward direction. This will be upward. Now T dash is already known in stable position, that is T dash will be 3 mg, because total mass was m twice m plus m, that is 3 mg minus 2 mg equal to who will go up? Twice m will go up with an acceleration a suffix a, that is acceleration of this mass will be g by 2 in the upward direction. It is shown here. Mass of this one acceleration of this mass will be upward direction, whereas B will come down in the opposite direction. Job number 16. If the work done in blowing a soap bubble of volume V is W, then the work done in blowing soap bubble of volume twice V will be. We have to find out. Now, as we know that work done, we know that integration of PdV. Now excess pressure for a bubble will be 40 by R, and here change in volume from V volume to twice V volume. What it means, 40 by R into 4 pi R square, the circumference area into thickness will give the volumes, small segmental volume, shell volume. And if we integrate, we have to integrate here. Now what to do, say work done will be W dash, and that will be how much, we have to integrate from radius R to 2 to the power 1/3 R, because volume V means 4 by 3 pi R cube, and that volume has increased to some other volume twice V, that means 2 times 4 by 3 R cube. The new radius will be 2 to the power 1/3, 2 to the power 1/3, here you can see 2 to the power 1/3, this one 2 to the power 1/3 into radius. Now this integration is not tough. Here 0 R to 2 to the power 1/3 into R, that will be the upper value. Now from here 16 pi t, integrating this we will get an expression like this, R square by 2, then substitute limit, you will get an expression like this. You have to do yourself, I am giving the basic guidance here only. And 8 pi t within bracket, an expression will come 2 to the power 2 by 3 R square minus R square. If you just open the bracket, and it will give an expression like this. Now this one you can say initially the work done was this much, because volume for that particular volume work done will be this much. You can calculate from 0 to, one more calculation you have to do yourself, that you find out this work done when bubble started from 0 to R. In that case you will get this expression. Now if we add these two, this work done from R to 2 to the power 1/3 R, and this work done is 0 to R, and sum up these two, you will see these two cancels, only thing left this one. That means for this part, this 8 pi t R square is the amount of work done for 0 to same amount you can see here. This factor is nothing but W. Then 4 to the power 1/3 will be there. Then 4 to the power 1/3, because you can see here this 2 to the power 2 by 3 will come. So just multiply 2 square, that means it will be 4 to the power 1/3. For this problem you have to do yourself, but this video cannot satisfy you. You have to solve yourself. You just get the guidance, you got the guidance, and you can solve yourself. Now job number 17, the differential equation of charging of a capacitor is as given below. Seeing the equation, we have to understand that there is a resistance in the circuit, one capacitor and a resistor in the circuit. If you take the standard equation, charging of a capacitor, then you will get this is a simple one. You take one capacitor, one resistance in series, and there is a source V, then drop across the capacitor Q by C, and rate of current, current rate of charge flow into resistance will be the potential drop. The sum of this all three will be 0. This will be negative. So this pattern is equivalent to this one. If you compare these two, that means 1 by K1 you can take R, and with coefficient of this one, 1 by C you can say K2, and V equal to this K3 also minus. If you come this side compare, and K minus will vanish, V will be K3. From here our requirement to find out here time constant, you know R into C is the time constant, and steady state charge when Q we have to find out. Okay, now here you know that time constant means R into C, this will give 1 by K1 into K2. Here RC means 1 by K1 only. Already you got it that 1 by K1 means R and K2 means 1 by C. Just reciprocal it. That means this will come 1 by K1 K2 RC time constant. Then charge C into V. Already you got C. That is K3. You got it. Comparing this, you can get K2. C will be 1 by K2. Now from here 1 by K2 or V already you got it. The V equal to K3. That product of these two will give Q charge. Now come to next job 18. A horizontal rod rotates about a vertical axis through one end A ring, which can slide along the rod without friction, is initially close to the axis and then slides to the other end of the rod. In this process, which of the following quantities will be conserved? Angular momentum, total kinetic energy, rotational kinetic energy. That we have to choose from these 4 choices. Now, as it is understood, now problem is like this. One rod is there, it is under rotation with angular velocity. Now one ring is here close to the axis of rotation. Now this ring will proceed in this direction. Now what are the energies can conserve? First, it will conserve angular momentum. When it is here, whatever angular momentum will be here, when it is going away, but angular momentum of the system will conserve because there is no loss of energy due to something. Now here kinetic energy of translation, as it is going this direction with the translational velocity, that will also conserve. That is answer B will be the correct choice here. Now come to job number 19. You can see here B is the answer. L and K, rotation. Rotational kinetic energy will conserve. Rotational kinetic energy, that is to be noted, because under rotation whatever energy it involves under rotation, that will conserve. Now next job is 19. A photon of energy 10.2 electron volt corresponds to light of wavelength lambda naught.